So, welcome to AI Engineer in 90 Days program. So, today is not just a theory, it's about understanding the technology and how the technology is moving, how the developer roles are changing, and how to grow or how to take your full stack developer career or full stack development track to AI, ML, Gen AI, Agentic AI. So, ML and AI engineers, we can say. So, today we'll have overview of all fundamental concepts of ML2 agentic AI. Tomorrow we'll have the complete roadmap from a full stack developer to AI engineer, a .NET full stack developer or .NET backend developer to AI engineer without learning Python, without learning mathematics, without switching from Microsoft platform to another platform. So let's start with so what is AI? Or before going to AI, we'll create a background here. Now AI created a fear in application development or full stack development world, or many full stack developer or application developer are thinking so AI is going to replace them. Now you should remember, so AI won't replace developers. So developers using AI may replace those who don't. So AI is not going to replace any developer, but AI is going to multiply your capabilities or add an extension to your capabilities so that you can develop, design, test, and deliver more faster, more modern way. So indirectly you can say, so AI is a multiplier who delivers the application, so entire team, including architect to deployment. And nowadays, employers are looking for those developers or those employees, those has capability to work with AI. So if you go to the traditional development, so development before AI. So earlier, so developers spent huge time writing a lot of code, so boilerplate code. In traditional development, so we write the code, we debug the code, we repeat, then we test. So as a developer, we write the code, debug and repeat, write the code, debug and repeat. So before AI era, so we can say we write huge boilerplate code. In a model development, so AI generate much of that. So AI generate much of the boilerplate code. So your role is changing. So in traditional development, we write the code, debug the code, and repeat the code. Now, maximum of these activities can be done by the AI. So your regular code, your boilerplate code will be now generated using AI. So we need to shift from just writing the code or debugging the code or repeating, writing the same code again and again. So as a developer, we need to shift from these three activities to solve the problems. So we should learn architecting the application. We should learn the problem solving skills. We should develop thinking. We should develop integration. We should able to use AI tools to improve our productivity. So instead of just writing the boilerplate code again and again, we should build fast. So nowadays, companies are not looking for just a developer to write, debug, and repeat the code. They're looking for a developer those can solve the problems, those can think, those can architect, those can integrate, those can use modern AI tools to speed up or build fast or develop fast. So that's what I told you. So AI is changing the software development role. So, for example, code generation, test generation, documentation, AI assisted debugging, API scaffolding. So, ChatGPT or Google Gemini or DeepSeek or Claude or Mini Velocity or many other AI tools are there. They can generate the code, they can test the code, they can create documentation of a code. They can also debug your code. They will help you to debug the code. They can also scaffold API. So you are in the .NET world. So they can generate all controllers, API controllers with everything. So API can write unit test, but still AI needs human validation. So AI can give you all these things. It will give you code, it will give you test, it will give you documentation, it will help you to debug, it will give you scaffolded APIs, but still companies need humans to validate, enhance, modify, arrange everything as per the requirement of the problem, as per the requirement of the client, as per the requirement of the use case or scenario. So as a modern developer, so we need to shift from just writing code to doing lot many things with that. So what is the feature of .NET roles evolution? So .NET developers need to shift to AI-enabled developer, and from AI-enabled developer, so we need to shift to AI engineer. So you should remember here, so .NET is not going to disappear. So many people are claiming on YouTube or broadcasts that companies will not need a developer. So this is not going to happen. So .NET, Java, Python, it's not going anywhere. So those those platforms will sustain in the future. Those enables us to develop AI-enabled applications or AI-enabled features. Those help us to integrate AI-enabled features. So you need to remember, so .NET is not disappearing, it's becoming platform for AI applications. And in tomorrow's session, I will explore you what we have in a .NET platform, and it is more than sufficient, and it's evolving continuously. So Microsoft is adding many things using which you can develop AI-enabled applications. You can integrate AI capabilities in your existing applications or new applications. So with the knowledge of a .NET, so as a developer, if you have 3 years, 4 years, 5 years, 8 years, 10 years knowledge, if you add OpenAI, semantic kernel, ML.NET, Azure AI services, RAG, Agentic AI, Generative AI, LLMs, it will open many doors of opportunities. And magic is you do not need to go to Python. You do not need to learn the mathematics or statistics for that. So everything is in line with your .NET platform. So you can utilize your experience, your skills to shift from a full stack developer to AI engineer. Now, a few of the job roles I had listed here, there are many job roles in AI. So generative AI engineer, AI application developer, ML engineer, NLP engineer, prompt engineer, AI solution architect, ML ops, we can say, AI research scientist. Now, why now? So if you came to me before 1 year or 2 year or 3 year back asking about AI, machine learning, I might have told you. So we need to wait. And now is the time when we can upgrade from a full stack developer to AI engineer. Now, why now? So rapid adoption. So now companies are adopting the AI models, agentic AI, generative AI, LLMs rapidly. Now there is hiring demand. Now, if you look at to any job site, you'll find there will be many jobs for Azure AI engineer or Azure AI services or ML.NET engineer. So hiring demand, productivity shift. So now companies are demanding a more productive developer. Those can develop AI enabled or AI compliant or AI integrated applications. So this is the right time. So early more advantage you'll get. So if you look at to the Python AI, ML AI market, it's little bit nowadays it's little bit saturated. So many people are learning ML AI using Python. But if you look at to the .NET platform or .NET AI, we can say in short. So still there is no saturation, but if you search for the job using keywords, those are available as the technologies in .NET AI track, you'll find nowadays there will be plenty of jobs. So you'll get the early more advantage of that. Fine. Now let's talk about the history of the AI. So you might heard about or hearing about the AI from last 3, 4, 5 years or 6, 7 years, but it's not the new field or it's not the new thing. It's very old thing. So it started in 1950. So when a Turing machine is developed or Turing test machine is developed. So if you want to know about this Turing machine, so there is one movie, Hollywood movie, Turing machine. So in that movie, they had shown how that you created the Turing machine. In 1980, expert systems, so 1950 to 1980, around 30 years it took to shift from Turing test to or Turing machine to expert systems of that. Then we'll find the deep learning. You got the AlexNet. Then we got the in 2023 ChatGPT 4 and ChatGPT. GPT-4 and ChatGPT 2. So GPT is basically AI behind ChatGPT 2. In between, if you look at, so what experiment happens? Turing test to expert systems in between this, so 1956, 1956. So there is a Dartmouth conference where many scientists came together to discuss about this new thing to utilize it in manufacturing or production. And in 1980, we got the expert systems. Now AI came to, so AI got more popularity in 1997. You might heard about this news. So Deep Blue, that is the computer who beats the Kasparov, the world chess champion. So that is the IBM Deep Blue machine who beat the world chess champion. Then we got the deep learning, then GTP3 in 2023, we got the ChatGPT, and 2025, rise of multimodal and agentic AI. So now you are living in the world of so multimodal and agentic AI with that. Now, if you look at to this particular journey, so you might find that things are very rapidly changing from 2022 to 2025. So biggest risk today is staying the same. So now a time that we need to start adapting or acquiring the new skills to become AI enabled full stack developer or AI engineer. Now let's have the overview of AI and machine learning. So what is AI? Artificial intelligence. Now I can tell you when I was in a graduation second year, so we were having Lisp programming, LISP, and Lisp was used to write the code for AI. So it's very old thing. It evolved over a period. Now, what is AI? So AI is the ability of machines or software to perform tasks that normally require human intelligence. So AI enables your machines or softwares to work like a human, to perform the task like human. Now, AI is the simulation of a human intelligence by computer systems enabling machines to learn, reason, and make decisions. So, what computer scientists are trying to do, they are trying to simulate human intelligence so that computers should able to, our machines should able to learn, understand, and make decisions. And we can say they are successful in their goal. So, if we look at today's world, that is called agentic AI. So what are the types of AI? So narrow AI, ANI, we can say specialized system that excel at specific tasks. So narrow AI is niche, or we can say small segment that focus on specific tasks for them, like voice assistants, your Alexa. So recommendation engines like product recommendation or movie recommendation in Netflix. So we got the narrow AI long back, so around we can say 10 years before. Now we have the general AI, AGI. So hypothetical systems with a human level adaptability across diverse tasks, still a research goal. So general AI, you can say. Now computer scientists are looking towards the next era of AI called super intelligent AI, ASI, a theoretical AI surpassing human intelligence in all domains. A long-term speculation. So this is still speculation. They are thinking that they will do it. They might not. But companies are investing money in ASI now. So AGI is already there. We are using AGI, general AI. So AI made up of multiple subfields. So AI is not one technology or AI is not one field. AI is made up of many things together. So machine learning, NLP, computer vision, robotics, expert system, and many more. Now, this is important line that we need to worry. So why we should adopt the AI inside our applications. So 64% of businesses now say so AI is enabling their innovation, with AI market projected to exceed $300 billion. Huge. Right. So in 2016, if you access various, you can say, surveys, you'll find 60% of the business now say AI is enabling their innovations. They are using some way, another way of AI in their day-to-day business activities, including production, sales, marketing, delivery, logistics, inventory. And the AI market projection is huge, so it's going to exceed $300 billion. Now, examples of some AI around us: Google Maps, route suggestions. So if you use today's Google Map, it's very intelligent. If you look at the Google Map 5 year back or 6 year back, it's not supposed to generate recommendation to you. So right now it's generating a recommendation about the routes, that this will be a shortest route, or so this route will have more traffic, how much time you need to reach your destination if you go by this particular route, or what are the patches inside the route where you'll find more traffic. So it's giving you all the recommendations. That is AI. Netflix recommendation, Face Unlock, Siri, Alexa. Besides this, we are using many things, ChatGPT. So nowadays, people are talking about, we can say, agentic AI. Before agentic AI, people were talking about generative AI. Before generative AI, so people were talking about just AI. To understand the generative AI, are the most popular implementation of a generative AI, that is called LLMs or agentic AI. So first we need to understand machine learning. So machine learning is the backbone or the core concept behind all AIs. So what is basically machine learning? So machine learning is a field of artificial intelligence or a segment of AI where we train the machines so that they will get the intelligence, and we can utilize those intelligence to perform some decisions or to do some kind of task. Now, the core idea, so instead of writing rules manually, feed the data to algorithms that discover patterns and improve over time. Now, what is the difference between the classical coding or programming and machine learning coding or programming? In classical coding or regular coding, what we do, we write the code around the rules. Fine. But in case of ML, so we'll not write the code around the rules. Instead of that, we feed huge amount of data regarding the problem and the solution of problem to various algorithms, so that those algorithms will discover the patterns, they learn the things from it, and they improve over a period and then we use it to perform the various tasks with that. So that is the major difference between the classical programming and machine learning. So if you code for machine learning and if you code for a classical application or ML enabled application, so this is the difference. For example, suppose if you want to write a program where we feed 10 numbers to the program and we will tell the program to give me prime numbers. In the classical coding or programming, what we do, we write step-by-step instruction. That is rule-based instruction. Get the number inputted, then check whether that number is divisible by 2 to number minus 1. If it is divisible by 2 to number minus 1, then it's not prime. If it's not divisible, then it's prime. That is the rule-based coding or programming. If you want to solve the same problem using ML application or ML enabled program, so what we do, so we feed many prime numbers to the algorithm. So we tell them, so these 100, 200 numbers are the prime numbers. And we also feed them, these are the numbers, those are not prime. So we will not write rule-based coding with that. We'll feed this particular thing to the various algorithms. Then what the algorithms will do, what the ML will do, it will find or discover the patterns. It learn on its own by discovering the patterns. And over time, it will improve. So as much as it learn about that particular data, so over a period, it will be improved. And then at the end, you can feed him the 10 numbers and he will, so it will able to figure out so prime numbers out of those 10 numbers. So this is the difference between the, we can see your classical programming or coding or ML coding or programming. Right. So machine learning is a subset of AI, so where systems learn patterns from data to make the decisions without explicit programming. So we are not going to program to make the decision based on the rules. We are going to teach them. So prime numbers are like this, and these are the numbers, those are not prime number, and they learn from it, and then they make the predictions. So what is the process of the ML? So the first thing will collect the data. So to train any, we can say, ML or to create or develop machine learning model or to make your program ML enabled. So we need to feed huge data, so it need a data. Then we do the feature engineering. So we'll tell the machine about that data. So for example, if I want to identify the image of cat, I want to develop application. So where I will show the image to that particular application and that app will tell whether that image is a cat image or not a cat image. So what I'll do, I need to feed thousands of cat images and non-cat images, dog, rat, mouse. And in future engineering, so I need to label that particular images with some attributes or characteristics. So what is the difference between the cat image and the dog image? Or this is the cat image. What are the features of that cat image? That for feature engineering that we need to do manually. So indirectly we sense labeling the images, not only labeling the images, labeling the attributes from that images also. The next step will select the model. So model is nothing but we can say algorithm. So there are many ML algorithms where comes your mathematics part. So there are many algorithms. So we have this various models of learning. We can use supervised, unsupervised, semi-supervised. We'll select the training model, then we'll start the training. After completion of a training, we'll evaluate it. So we'll test it, evaluate it. And if we found it is accurate as per your requirement, if it's generating the accuracy, so we have various, we can say tests that we can perform to check the accuracy level of your ML. If it is passes that, then we deploy it. If it doesn't passes, then we'll do the process again. So future engineering model selection, future engineering, you don't need to repeat again, but model selection and training, evaluation. So what are the key components of your machine learning? Training data, features for input variables. So features are the, we can say, properties भी बोल सकते हैं, attributes about the data, training data. Then we select the mathematical model or model, mathematical function. Last function to measure the error. There are the key components of your machine learning. There are many ML applications. The most popular application that you might have used is email spam filtering, product recommendations, fraud detection, medical diagnosis, autonomous vehicles. Right. So current market is around 6.4 billion to around 24 and is expected to grow by $36.1, but this number is different by billion by 2023, so 2030 ML market. So before I told you the AI market. Now, how machine learning works, that I told you, data collection. So you need to collect the data. That's why you find every big tech is collecting the data. Everybody is collecting the data, your personal data, financial data, your social media data, your geological data, your geospatial data. So everything, your behavioral patterns. Nowadays, even uh, governments are drafting their policies in such a way that they will get a huge data. So they are collecting the data. So data is new oil. So that was the term used due to this particular thing because to train the ML, we need huge data. Then you need to prepare the data because entire data might not be useful as per the application or your task requirement or your output requirement. So you need to clean that data, transform that data. Then you need to select a model. So model selection, so algorithm choice. Then model training. So after model training, so we'll evaluate the model, we'll test the model for the performance. Once model working properly, so we can do the improvements. So fine tuning we can do using various mechanisms. Then we'll do the prediction. And if we find the model is predicting or doing the things as per our expectation, we'll deploy it or we'll go back to model selection, model training, evaluation, improvement, and prediction. Now, classical machine learning. So this is machine learning. So machine learning evolved in two steps. One is classical machine learning, another is modern machine learning or deep learning. So classical machine learning is a foundational algorithm that power the intelligent system. These are the fundamental algorithms. Now, classical machine learning refers to traditional algorithms that rely on structured data like spreadsheet, SQL tables, and this data often require future engineering. You need to do the labeling, assign the meaning to the values from that particular data, assign the properties to that particular data. That is called future engineering. Now, future engineering process where humans manually define which piece of data the model should pay attention. For example, to identify the house price, look at the square footage and number of rooms. So we'll label the data, we'll tell the model, so which data you should be worried, you should be focused. In classical machine learning, that is called future engineering. Now, there are types of classical machine learning or models or algorithms, we can say. The first is supervised learning. The model trained on labeled data. In supervised learning, so your model, ML model, is trained on labeled data. So when we provide the data to supervised learning, we can say model. So we give the label data. We'll tell this is a spam email, this is not a spam email, this is a spam email, this is not a spam email. And what it does, it will find the patterns and it will learn so how the spam email look like. The unsupervised learning, the model find hidden pattern in unlabeled data. So here we not do the labeling. So in unsupervised, so we'll not guide the model. So in supervised, we are guiding the model that this is the spam mail and this is the not spam mail. And we are giving so hundred or thousands of spam and not spam mail classification to your machine learning model. But in unsupervised learning, the model finds hidden patterns in the unlabeled data. For example, we are giving a group of customers who has similar buying habit. We are not labeling what they are buying and what they are not buying. We are giving them a customer data and it will automatically group the customers with similar buying habit. This is very popular with recommendation system. So when Amazon gives all customer data, so it will automatically find the similar buying habits, and based on that, if you go to the Amazon website to buy the laptop, it will recommend you that other customers who bought this laptop is also about this particular product. So it creates the grouping or clusters based on the hidden patterns in unsupervised learning. Reinforcement learning, the model learns by trial and error. Now, this is for very critical, we can say, systems like we can say chess game. If you want to build AI model which will play the chess. So reinforcement learning, the model learns by trial and error to achieve the goal. It will receive the reward if it is correct actions. And based on that rewards, it will learn. So reinforcement learning. So there are many, you can say, uses of classical ML. So finance, credit scoring, fraud detection, algorithmic trading using a simple method. And so we give the bunch of transactions and we'll tell them this is a fraudulent transaction, this is, we can say, a right transaction. Then it will automatically learn from it and then find the pattern. When you try to do the transaction, it will detect the fraud in your transaction. So healthcare, this is prediction, patient risk stratification with decision trees. E-commerce recommendation engine that I already told you. Price optimization with collaborative filtering. So if you know the Azure, so in Microsoft Azure, we have Azure Advisor, which will help you to optimize the price of your Azure services based on many data collected during monitoring. Manufacturing. So predictive maintenance, quality control with anomaly detection. There are the few areas where we can use the classical ML. So strength and when to use works well with the smaller structured data set, tabular data or CSV. So you have a smaller, medium-sized data, it works absolutely fine. And data in the form of table or CSV structured data. Easier to interpret and explain. Structured data is always easy and easy to interpret and explain. So it's critical for regulated industries. Faster to train and deploy than deep learning models. It's very, we can say, fast to train and deploy the models in classical ML. So the modern ML is deep learning. Now requires manual feature engineering. So that is again one limitation. So domain expertise needed. So if you are working with a bank fraud detection, then you should have banking domain knowledge to identify the how the fraudist or we can say fraud transaction can be identified. Best for problems with well-defined features and moderate complexity. Now, so ML has classical ML has limitation. The feature engineering that is the bottleneck. The classical ML, a human expert must manually identify the important features from raw data. That is very time-consuming process. So if you have 1,000 images, so you need to label the images, cat images or dog images, their attribution features. It's quite time-consuming process. Poor handling of unstructured data. If you provide the unstructured data to ML, then it's little difficult for classical machine learning. So if you provide the unstructured data, data in the form of images, video, audio, then classical ML algorithms or models will not work properly. Because create labeling the data or doing the future engineering is very challenging in audio and video. So designed to work more efficiently or accurately with the structured data. So its algorithms like linear regression, random forest are designed to work more accurately with structured data. So unstructured data like grids of millions of pixels, complex pressure waves over time, that is audio, natural language, the nuisance or sarcasm or grammar of human speech. So this kind of data, when fed it to ML, classical ML, so classical ML accuracy is very less. The data saturation point. So classical models reach a point where adding more data doesn't make them any smarter. So up to one level, feeding the data again and again and providing more and more and more in data will not create that much improvement in the prediction level or result level of your classical ML. Their learning capacity is limited by their mathematical simplicity. So we have few techniques by which we can solve this problem up to certain extent, but definitely to locker to data situation point. So by providing 1,000 cat and dog images, if your algorithm got 70% accuracy, then providing 5,000 cat and dog images will not increase that accuracy from 70% to 90%. It will increase only 70 to 74% or 5% to them. So that point is called data saturation point to them. So then you need to change your model. You need to change your algorithm. And that gives birth to a next level of ML that is called deep learning. And your generative AI is based on deep learning. So deep learning is the foundation of your Gen AI. Now, so deep learning, so neural network that learn hierarchical representations from raw data. Fine. So you might heard about the neurons, or if you know about the human brain structure. So it tried to simulate the human brain structure in deep learning. So we called neural network. So deep learning is also called a neural network at scale. So deep learning uses artificial neural networks with multiple hidden layers to learn complex patterns from raw data. So it can work with very complicated data, very large data, and it can identify very, very complex patterns from your raw data. Now, the key difference between the classical ML, so features are learned automatically, no manual feature engineering required. In neural network, you do not need to do future engineering. So when you provide the dog and cat images, you do not need to tell the model this is the cat image, this is the dog image, and these are the attributes that are different from that differentiate the cat from dog. So you don't need to do it. That is called feature engineering. So feature engineering you don't need to do in deep learning. Now neural network layers. तो थोड़ा सा टेक्निकल हो जाएगा अभी. So when we create a neural network, it will have some layers. So layer based, and you can have many layers. So first is input layer that will be always there, where from you can feed the input to your network. Then it have many hidden layers. It can be hundreds, it can be thousands. So as much as many layers are there, it will learn more and more, and it will learn more complex patterns. And finally, we have the output layer. Now, there is one more thing, backpropagation, the algorithm that adjusts network weights based on the prediction errors, enabling learning. So these layers are designed in such a way that they can propagate backward. So if they find the errors in the prediction based on the weight of the nodes from your network tree, they can backwardly propagate to learn more and more, we can say, things about your data. So challenges are it requires large data set and significant compute power. So for deep learning, we cannot use CPU. So classical ML algorithms or models can be trained on your CPUs. For deep learning, we need the GPUs and TPUs for training. So you can also use the CPUs, but it will take days to learn a small thing. So for deep learning, we'll use GPUs and TPUs. So AlexaNet, so that is your Alexa, ImageNet, providing deep learning superiority in image recognition. AlexNet is an first, we can say, deep learning based ML who own the ImageNet, providing deep learning superiority in image recognition. So you need tons of data. So perform best with unstructured data, so it works more accurately with unstructured data like images, audio, video, natural language text. That is your in the Marathi, English. Now, deep learning also has models, few common models are CNN, So convolution nets, RNN, recurrent nets, GAN, generative adversarial, TF transformers. So just like supervised, unsupervised, reinforcement, semi-supervised, here also we have different architectures. Those can be used to create your neural network. So we can use CNN or RNN or GN or transformers. And there are many deep learning applications, face recognition, speech recognition, language translation, autonomous driving. And deep learning is a foundation for your generative AI. Now, before going to generative AI, let us have a comparison of classical machine learning and deep learning. The classical machine learning requires structured tables, input data. Deep learning handles raw images, text, and audio. Human efforts high, manually define, we can say defining features. Now low, human efforts are low in deep learning. You don't need to manually create the labels and attributes and properties. So model learns feature itself. Accuracy. So saturate quickly. Scales with more data and compute. Now explainability high, easy to see why decisions were made. So you can explain in classical machine learning, so why this prediction generated by ML, but in deep learning is quite difficult. It's black box type of thing. It learns on its own and it find the patterns on its own. Everything it will do the own. It's little bit difficult for us to predict why this outcome came from ML. So what is generative AI? So AI system that create new content like text, images, code, music, and more that we are using nowadays. Now, generative AI is creating, not just analyzing. So the ML, whether it is a classical or modern, that is deep learning, neural, they supposed to analyze the things, and from that they should learn the things and they will predict the things. So generative AI refers to AI system that create new original content based on the patterns learned from training data. It's about the generation, not about the prediction. It will generate the new things from existing data. So from learning from existing data, not from copying from the existing data, but learning from existing data. Unlike traditional AI that classifies or predicts Gen AI, unlike traditional AI that classifies or predicts, the Gen AI generates entirely new output like text, images, music, video, code. And foundation models are large pre-trained models like GPT, so DALI, stable diffusion, mid-journey, adapted for various tasks. So every model has its own, we can say, application. So some of the common applications are generative AI, content writing, code generation, image creation, drug discovery, product design, music composition. So right now, many companies are focusing on creating the generative AI to generate the code, write the software applications. Unlike traditional AI that classifies or predicts, Gen AI generates entirely new thing that I told you. The Gen AI market surged from experimental in 2022 to multi-billion dollar industry by 2026. So challenges are hallucinations. So what are the challenges in generative AI? Hallucinations. Copyright concerns, defects, quality control remain active issues with them. Legal issues will be there. Now, generative AI has hallucination problem since it learns on its own using deep learning. So it scans through your entire internet or tons of data to learn the things. So it might produce some hallucinations. It may create copyright concerns or defects or quality control remains active issue then. So handling the quality of the generated output is very challenging. So you may say AI to generate a person who is eating vada pav. So what kind of problem may happen there? It may create a person who is eating the vada pav using left hand, or instead of vada pav, it might had only vada there without pav. So this kind of issues you may get in a generative AI. That's called hallucination, copyright concern, defects. Quality control is again very challenging in generative AI. Still, many companies are acquiring and spending huge amount of money or investing, we can say, huge amount of money in a generative AI. So if you look at to the data, you might come to know this. So 200 million plus ChatGPT users are there. 60% developer adoption. So nowadays, 60% developers are using Gen AI tools to generate various things, images, animations, effects, templates, codes, and this will go up to $6 billion by 2022. These are just predictions. These numbers are very large when it comes actual. So what is the difference between the predictive and generative? So primary goal of predictive AI is forecast, classify, or recommend, and generative AI to create, draft, or synthesize. Now, output in the predictive AI numbers, categories, probabilities, labels. For example, 95% chance of server failure, or this mail is a spam. Generative AI is original artifacts. Block of code, it may generate a block of code, an essay, it can write an essay, it can draft a letter, it can create legal document, it can create any image, graphic design image, it can generate a video, it can generate animation. So if you look at the relationship with data, so find the hidden rules and trends within existing data. So predictive AI will try to find and hidden rules and trends within existing data. Now, generative AI learns the structure of data to build new data that looks similar. So it will not learn, we can say, rules and hidden patterns. It will look at to the structure of data, and based on the structure, it will generate the new data that looks similar to that particular structure. So usually structured data like databases, logs, telemetry in case of predictive AI. Now in generative AI, usually unstructured data, natural language prompts, rough sketches like this. So one of the application of generative AI that's very popular nowadays is called large language models, LLMs. Now what are the LLM? So imagine computer program that has literally read millions of books, articles, websites. So since I read so much, it has learned the patterns of human language. So LLMs called large language model. So it will learn from tons of data. So learn the patterns from tons of data. So it go through millions of books, articles, websites, everything that is available. And it go through everything and it will learn the patterns of human languages. And LLM is basically a super powered predictive text engine, we can say, like search engine, like autocomplete on your phone, but smart enough to write essays, answer questions, and hold a conversion. Now, autocomplete what does? It generates one or two words based on the previous words you had inputted. or the characters that you had inputted. It's similar to that, but it's not to complete. So it can write entire essay, it can draft entire letter, it can answer question, it can solve the question papers. It can also remember and hold the conversion. Now, what is the brain behind the LLM? So before 2017, AI read the text word by word. So what is the magic in LLM? So before LLM, so AI read the text word by word, often forgetting the beginning of long sentence by the time it reaches to the end. So if it has long sentence, so it try to learn and understand word by word, and it's always happen. So when it reached to word number 10, it might forget what was there in the first position or first word or second word. So indirectly, it will not able to attach the meaning of a first word, or it will not able to find out the attachment of the first word with the 10th word or 20th word of them. And to solve this, so Google had introduced one transformer architecture. It introduced something called self-attention analogy. So transformer architecture based on the self-attention. Now think of being a crowded room. So how we can understand this? So you think you are in a crowded room, even with all the noise. You can pay attention to just a person you are talking to. So you don't get confused. So if we have 1,000 people in a conference hall or at a marriage hall, if you're talking to X person, so even though all these 1,000 persons are talking to each other, so it will not create any kind of problem with you because you pay attention to X person. So that is called self-attention model. And the self-attention model gives birth to a transformer architecture. Now, self-attention allows the AI to look at the entire sentence at once and figure out exactly how every word connects to the others, no matter how far apart they are. Fine. So this is the transformer architecture, and due to which this LLMs got the capability to learn thousands of pages or thousands of lines, or crores of lines here, depend on the size of the model. Now, pre-training, reading the internet. So what LLM does? So in pre-training, the AI is fed massive amount of text from internet. It learns the grammar, facts, reasoning, but it doesn't know how to follow the instruction aid. It's like a student who has read a whole library but hasn't taken a test yet. That is called pre-training. Fine-tuning, so learning to behave. So next humans train the AI to be helpful and safe. They teach it to answer as an assistant, write code when asked, or refuse to answer harmful questions. Fine. Now, scale the size of a brain. So when we talk about parameters, think of them as the neural connections in the brain. So if you look at to any, we can say, if you ask to any doctor, so how many connections we have in the brain? So the doctor will tell you, so one small dot from your brain contains millions of connections. So if you count entire collections, it will be many trillions. So when we talk about parameters, say parameters just like that. So think of them as the neural connection in the brain. So this generative AI can scale to size of the brain. Sorry, LLMs will scale to size of brain. So more parameters usually mean a smarter, more capable AI. Older models had millions of parameters. and GPT-3 had a massive, that is 175 billion parameters. So today's top models like Gemini, Claude, and GPT-4 are even larger and more complex. So they learn from that particular connection. So what can they actually do? Because they understand language and logic so well. The LLMs aren't just for chatting. They can write completely new text, email, stories, reports, summarize 10-page documents into a single paragraph, translate languages instantly. They can generate HTML, write C-sharp logic, or find bugs in your script with them. So context window. So AI short-term memory. The context window is how much information the AI can hold in its memory at one single time. And we measure this in a token. So how many tokens it can hold at one single time in AI memory. Which is token is basically piece of word, we can say. So old models could only remember a few paragraphs of the conversation before forgetting what you said earlier. Modern models so have context windows of 100K to 1 million plus tokens. This means you can upload an entire 500 pages book or massive software project source code, and the AI can analyze the whole thing at once without forgetting the beginning. So as the context window of AI is going to grow, so they can solve more and more and more large problems or more and more complex problems with them. Now, there is one more thing that is happening, multi-model. It's not just text anymore. So previously, it's supposed to work with only text. Now it's multi-model. So modern LLMs are multi-model. So multi-model simply means multiple models. So early LLMs were blind and deaf. They only understood text. New generation models like GTP 4.0, Gemini, and Claude have evaluated. Now they can look at images, listen to audio files, match videos, and understand them just as well as they understand the text. Fine. So if you take the photo of your a blood test, and if you upload to ChatGPT, if you tell it to analyze, so ChatGPT can analyze because modern LLMs can work with multi-model data out there. Now, other siblings of LLM. So similar to LLM, we have other, we can say, types of generative AI. So if LLMs are the writers of the generative AI family, there are some siblings like image generators, Dali Mid Journey, they generate visuals, or we can say Nano Banana or many models of that for image generation. Audio generator, so they generate basic or human-like speech. Video generators like Sora, Viewer, they generate moving pictures and senses. So LLM generated text. Similar to that, we have other, we can say, types of LLMs or large language models of that. Now, the next important thing in the AI track is the prompt engineering. So when you work with the LLM, so you should tell, or when you work with the AI enabled tools or LLMs, like whether it is a video generator, audio generator, or whether it is a text generator, so you need to tell the AI what to generate, how to generate, and that particular area or that field is called prompt engineering. So prompt engineering means designing better inputs. So what is prompt engineering? If LLM is a super intelligent intern who has read every book in the library, so prompt engineering, the art of giving that intern a clear, specific, and actionable instruction so they give you exactly what you need. Fine. So if you have a huge library which contains physics, chemistry, bio, all books. So if your LLM reads all these books. So prompt engineering is a way by which we tell LLM what exactly we want, what exactly you need. If you tell the LLM what you will read, then LLM will give you tons of data. If you ask the LLM about a specific thing, what will be the tentative size of human heart? So LLM will come to know it will go only to biology section or go to the books or a section of the data that contains human biology. So prompt engineering is the art of giving them into clear instructions, specific and actionable instructions, so they give you exactly what you need. In simple terms, the quality of the output in LLM depends on the quality of the input. Why do we need it? So LLMs are probability machines. So they do the probability in combination based on your input, and they will generate the output. So if you give a vague prompt, the AI has to guess what you want. So prompt engineering reduces the guessing and guides the AI toward the right path in its brain. For example, if you tell the LLM, write a code for login page, the AI might give you Python code, or it may give you PHP, or it may give you HTML. It might use a database or don't use database. What prompt engineering will do, so engineer prompt, write a C# code snippet for an e-sporting core API login controller using JWT token authentication, include comments for each step. Now the AI has a specific map to follow. So this is the prompt engineering. So common techniques in the prompt engineering. There are three techniques you can teach students to instantly improve their results. Zero shot prompting, just asking question directly. Translate hello to Hindi. The first technique is zero shot prompting. If you want to do very small thing, so you can directly ask it just like question, translate hello to Hindi or order. Few short prompting, give the AI a few examples so it understands the pattern you want. The small is too big, cold is too hot, fast is too blank. The AI sees the pattern is opposite and it will find out fast is too slow. Now, chain of thoughts is third way of third technique of the we can say prompt engineering, TOT. So asking the AI to think step by step. This is a magic phrase that makes the AI better at logic and math because it forces it to write out its reasoning before giving the final answer. So when you say step by step, do this step by step, think step by step. So it will not only just generate the output before generating the output. So it will reason it and then it will get you the final answer. Rule prompting, this is very popular technique. This is very hack, we can say, is one of the most powerful hack in prompt engineering. It involves telling the AI to adopt specific persona or identity before it answers your question. This is very interesting and this is very popular. This hack gives you many times a 90% correct result. Without a rule, the AI gives a generic middle of the ruled answer. With a role, AI filters its knowledge to match the expertise and language of the specific persona. So how to structure a role prompt to get the best result following the simple formula. So act as a persona, act as a software developer, act as a advocate, act as a, we can say, police inspector, act as a doctor. Your task is to जो भी task है. Your goal is to, and this is your audience, the target audience. This is the common structure of the, we can say, role prompting. The example for coding student, act as a senior .NET developer with 10 years of experience. Your task is to review this block of code. Your goal is to suggest 3 ways to make it more efficient. The audience is fresher who just learned C#. So everything is included in this particular prompt. Now it will reason it will arrange it, and it will generate the output. This is the, we can say, persona-based prompting or role-based prompting with that. Now the next concept that we have in Stack is RAG. So retrieval augmented generation. So RAG equal to LLM plus your data. So what LLM does, it will go over the internet and it will learn millions of words. It will reason millions of instruction statements. So what RAG does, so RAG is a LLM, but on your data. So what is RAG? So retrieval augmented, we can say, generation. So RAG equal to LLM plus your data. So think of standard AI like a student who graduated in 2023. So your standard AI is just like a student who graduated in 23. If you ask them about a news event from 2024, so you may say, I don't know. It's out of syllabus. Or a private document on your laptop. They will either say, I don't know, or worse, what is the most critical situation? It will hallucinate. They will make up believable lie. Fine. So to avoid this, we got the RAG. So RAG works in a simple 3-step cycle. You can remember it, RAG. So in RAG, R stands for retrieval. So when you ask a question, the system doesn't go to AI 8. It first searches your private knowledge base, whatever the PDFs or databases or folders you provide, to find the most relevant paragraphs. Then it will augment it. In next step, it will augmentation. The system takes those relevant paragraphs and augments, adds to them to your original question. And last is generation. The AI receives a get prompt that says, here is some secret information, and retrieve data. Now, using only this info, answer the user's questions or user query. This is RAG. Now, let's learn this by example. Suppose, imagine an employee at your training institute, so in Aratic, asks, what is the policy for sick leave during the cricket tournament? So without RAG, if you use the general AI, the AI may say most companies give 10 days of leave. And it's generic answer. What it does, it will go to the internet, it will study lot of, we can say, company documents, very many company, different company documents, policies, and then they generate answer. And that answer may be vague. So most companies give 10 days of leave. That is generic and possibly wrong. With RAG, what it does, so it will search the PDFs or documents or handbooks only from Aratic. It will not go outside the Aratic. And using that clear thing, so it finds the paragraph. So during sports event, employees can take 2 days of leave, special leave. The AI will answer according to Aratic Handbook, section 4. So you have 2 days of special leave for the tournament of them. So here comes the RAG. Fine. Now, the next concept that we have in AI world is model context protocol, MCP. Now, MCP is like your HTTP. the universal standard connecting AI models to the real world. The MCP is the USB-C port of your AI system. So, Model Context Protocol, MCP, is an open standard by Anthropic. So, November 2024, connecting LLMs to external tools and data. The MCP is a protocol, Model Context Protocol, which will help you to connect LLMs to external tools and data. So, problem it solves: LLMs have frozen knowledge and can't interact with external systems on their own. So, before MCP, most of the LLMs we work with a frozen knowledge or frozen data, that data they have. They cannot go beyond that. They cannot talk with external systems right, on their own. So MCP provides a standardized language or AI to communicate with databases, APIs, web services, and applications. Using an MCP, so your LLMs can talk to databases, APIs, web services, applications with them. Any type of data source. Like HTTP standardize the web communications, MCP standardize how AI applications access external capabilities. Now the components of MCP are MCP host AI app, the components here also MCP host AI app, client translator, server service provider, transport layer. So JSON RPC 2.0. I will not worry about this. So if you are getting bored, no problem, we can skip that. Transport Studio for local resources, fast synchronous and SSC for remote resources, real-time streaming. Adapted by Cursor, Celine, and enterprise platforms for building production-ready AI agent system for that. So MCP with, we can say, generative AI with context, create a base for your agentic AI. So the next level of AI that we have is agentic AI with them. Now, agentic AI, like chatbots or autonomous agents. So agentic AI refers to systems that autonomously plan, reason, execute multi-step tasks, and adapt to achieve goals. So in generative AI, as a human, we need to plan what to do, how to do. Then we need to tell the generative AI, please do this for me. They need to do something for you, then you need to reason it, accept it, and execute it. But in case of agentic AI, so all this will happen autonomously. So planning, reasoning, execution, adoption, and achieving the goal. Now the key difference is traditional AI respond to prompts. Agentic AI takes initiative, uses tools, and pursue the objective or achieve the objective. Then. Fine. So core capabilities. The goal is decomposition, planning, tool use, memory, and self-correction. In generative AI, if you tell the AI to generate X image like this, if it generates some image, you resonate, and if you feel that there is some kind of problems in this image, you need to tell the generative AI, so please make these changes in this particular image, remove this particular section, add this section, make it more professional or make it more dark, more light, whatever. But in case of agentic AI, you don't need to tell. You just need to give him a goal, what you want to achieve. So it will decompose that goal, plan it. It will automatically select the tool based on the goal. It will also enable the memory, and it will do the self-correction on its own. Fine. So that is the beauty of your agentic AI with that. Now design patterns, React, reflection, tool use, planning, multi-agent collaboration, human in the loop. So these are some design patterns that used in agentic AI. Now, market prediction $7.8 billion today, expected to surge $52 billion by 2030. That is the just predictions. So 40% of enterprise applications will embed AI agents by end of 2026. You might had uh, got the taste of this. Nowadays, if you go to an e-commerce site or any website, or if you go to banking mobile app, they have a chatbot to that, and it's AI based, agentic AI. That is the AI agent which is talking to you. There's no human behind it. It's doing on its own. Fine. So 57% of organizations now deploy agents for multi-stage workflows, including cross-functional processes also. Now, agentic AI trends are, so we can say surge in interest. So 1,445%. So huge. So there is a growth of 81% in plan complex cases and 80% measurable return on investment. So this trend is going to go for few more years. Now there is one more AI that is coming, local AI. Local AI running AI models on your own hardware, so private, fast, and offline capable. Now, currently, whatever the AI models that we have, those are available on net or cloud. So you need to run them. So you need to feed your data, your input, and that data goes to cloud, that goes to third-party server. So if you don't want that, if you have a privacy concern, legal concerns, then we need to go for local AI. The privacy and data sovereignty, data never leaves your device. No server logs, nothing there will be on server. If you use the local AI, zero latency. So your cloud-based AI has latency issue. It eliminates 200 to 800 millisecond cloud round trips, instant responses, offline capability, work on planes, remote locations during outages if you do not have the cloud connectivity or internet connectivity. Cost control, no per token API charges. You don't need to pay for every token. Nowadays, if you go to ChatGPT or Gemini, what they do, they charge based on the token uses. So free after model download, once you download the model, so you can use it locally without any kind of cost. So for model, you need to pay. So regulatory compliance. So if you have a healthcare data or defense data or legal required local processing, in that case, we'll use the local AI. So Olama is simple CI example of the local AI, LM Studio, MLX Apple, quantization hardware. Okay. So Olama is simple CLI to run LLMs locally. It's command line interface using which you can run the LLMs locally. So Olama 3.2 or Mr. or FIFO or Gemma 3. So you can download the model locally on your computer and using, or you can say, Olama CLI, you can use it. So LM Studio, so desktop GUI for downloading and running local models. MLX Apple, so optimized for AI on Apple Silicon hardware. The quantization, so GGUF or GGML reduced model size 4-bit for consumer hardware. So it will compress the models. hardware. So you can use the Apple M series or NVIDIA RTX or even smartphones with NPUs. So CPU, GPU, TPU, and for smartphones, you'll get the NPU. Then you can use those NPUs for local AI. Now, AI tools and platforms. So you know this. I don't think so. It's Mukita, Bathan, Claude, ChatGPT, Gemini. So open, we have the Llama, Missile, Velocity, many AI tools for that. Now there is one more big challenge for AI is ethical implications. Now let's go for what are the ethical implications of the AI. Bias and fairness. AI system can perpetuate or amplify societal bias present in training data. That is big challenge. Fine. So bias and fairness may be a problem. That will be a big challenge because internet is open. Everybody is putting whatever they want to put on internet. So some people say the 1972 war is won by the Pakistan. Some people say it's won by the India. So if AI works using that particular data, so it may create a bias and fairness problem. Privacy. So AI processes vast personal data. So raising concerns about surveillance and the data rights. So nowadays, every device is collecting everything. Even government also want to control your privacy. So the TV that you are using or set-top box that you are using nowadays, they are capturing every moment of your TV. They are learning which program you're watching, how much time you watch that particular program, and they're sending the data to servers. So privacy will be a concern. Now, government also passed one new rule. Every medical store should have one camera, so CCTV installed, and that is special type of CCTV which will collect the data from medical shop and it will directly send it to government servers where they can watch you what you are buying from the medical store. Privacy. So privacy will become the problem in AI, and AI will not go. AI will not think about the privacy. If they got the data, it will utilize it and it will generate it. Transparency. So black box AI models make decisions that are difficult to explain or audit. That is a very tough thing. So how this outcome came, so how this decision is made, it's very difficult to explain because the neural network based or deep learning based models are just a black box. How they learn from patterns that is depend on their own. Now, job displacement, AI automation transforms labor market, requiring reskilling and readaptation. So that you need to focus. Fine. There are some, we can say, ethical challenges, deepfake and misinformation. So generative AI creates, so we can say convincing deepfake contents, undermining the media trust. Accountability when AI causes harm, so who is responsible? Developer, deployer, user, company. That's again a challenge. Environmental impact. So training large AI models requires enormous energy and compute resources. And this is a problem. So Maharashtra government was very happy and announced that so big companies, tech companies like Google or we can say Microsoft want their data centers to be in Maharashtra, Andhra Pradesh. So our government is very happy with this. But as per my knowledge, so government did not allow them to set up the data centers in India, especially in the areas like Maharashtra, Andhra Pradesh, Tamil Nadu, Kerala. because setting a data center doesn't generate many jobs. Data center will generate few jobs, few, not many. But it needs huge energy. It needs huge water for cooling the resources, compute resources of that. And our government is becoming happy that all these big companies are setting their data centers in India. Fine. So data centers will not generate that much employment, but they will consume enormous energy. And energy will be a challenge. And water will be again a challenge because to maintain the cooling, huge water coolers they use, and it needs tremendous amount of water. So the best place for data center is they can go for Himalaya, so cool places. If you look at Europe and America, having very good quantity of land that is very cool, ice, but still they are throwing the data center out from Europe and America because they know they are harmful for the environment. They are impacting on the environment. So this is again one challenge of AI with them. So training large AI models require enormous energy and compute resources with them. Okay. Now this